Good afternoon. Thanks for having me. My name is James Carpenter, as you just heard. I'm from the European Space Agency. I work in Directorate of Human and Robotic Exploration. I'm going to talk to you today about what's happening on the moon, mostly what we in ESA are planning to do on the moon and what we're doing now, but I hope also through that to give you some idea of the scope and scale of what is coming in lunar exploration, and that this is, I think, a very exciting time to be alive. There's some very exciting things coming. Maybe just to give you a bit of background on myself, I live in the Netherlands now, working for ESA. I work at the European Space Research and Technology Centre, ESTEC, which is the European Space Agency's largest centre, based in the Netherlands. I'm British, you can probably hear that. I did my undergraduate degree at the University of Leicester in physics with space science and technology. Went on to do a PhD in space instrumentation at Leicester before working there on a number of space projects, and then moved into the European Space Agency in 2008. So that's a bit of background about me. The moon. So ESA is working on preparing a lunar exploration program for the future. And this is in the context of something which is quite extraordinary that's happening now. So you recall, the Apollo era of the 1960s and 70s was really the first and only time in human history that humans have stepped foot on another planetary body. And what happened there really transformed our understanding of what was possible for humans to do, but it also completely transformed and shaped our understanding of planets in the solar system and even the early Earth. Then there was a hiatus where not a lot happened. And then what we've seen in the last few years is a resurgence of interest in lunar exploration from around the world. We see different countries, different actors, the public sector, the private sector, multiple agencies coming together and going to the moon, to prepare going to the moon. And this has been very exciting. Now, what's driving that is a change in technology, change in the capabilities that different countries have, an increasing understanding that we really don't understand much about the moon scientifically, and there's so much more to learn about the universe and the solar system, the Earth, and the history of planets by going there. We're also finding that the resources that could be on the surface of the moon could have applications for future exploration and for potentially for Earth one day. So there's a growing drive to go there and explore. And so in ESA, what we're doing is we're preparing a program that would allow us to understand how to live and work in the lunar environment, that would identify potential resources and establish how we might use those resources in a responsible way, to establish the moon as a sustained platform for scientific research into the further future, to make sure that we create roles for European industry and commercial opportunities as well for the future, that we build an enabling international partnership that allows us to do this in the near and the long term, and that we learn lessons and build capabilities that are going to enable exploration of Mars. And I think this international aspect is really important, because as we go on to the moon and beyond, I think one thing that everybody's beginning to really understand is that this is not something that individual countries or entities are going to do on their own. It's going to be something that is really an international endeavor. It's going to be something that we do as a species, not as countries. And I think that's a remarkable next step after the international cooperation on the space station. So as we think about the themes of what we're going to be doing at the surface of the moon and around the moon, in terms of scientific research, we're going to be looking at planetary sciences, we're looking at the history of the solar system, the different environments that we find there, we're going to be looking for resources for the future potentially. I'll talk more about resources in a moment. We're going to be trying to understand what the biological effects of being in this environment are, both for humans and for the biology we bring with us. And we're using the lunar surface as a platform to perform astrophysical measurements looking out into the cosmos. In particular, for astrophysics, there's a particular epoch of the history of the universe called the cosmic dark ages, when the first cosmic structures have been formed. To look at this, you want to look at very long wavelength radio, and actually the only place in the solar system you can go where you can't see the Earth in radio is the lunar far side. So it turns out this is a great place, potentially the only place to go and do this kind of astrophysics. And to do all this, we're going to need a bunch of different technologies. We're going to need transportation technologies to get there. We're going to need energy, mobility, robotics, autonomy. We need to be able to communicate and navigate to support the life that we bring with us. and to utilize the resources that we find locally. So putting all that together, this is what we need to try and achieve. So the first steps for us are the projects we're actually working on now. So what you see here is the Lunar Gateway. And the Gateway is an international project which has been put together by the United States through NASA, the European Space Agency, the Japanese Space Agency, JAXA, and the Canadian Space Agency, CSA. There's some involvement potentially in the future from Roscosmos and Russia as well. And we know that there are other countries that are also involved. And what you see in this image on the far left is the Orion vehicle. This is the US vehicle that will take crews beyond low Earth orbit and into deep space for the first time since Apollo. And at the back end of this is the European service module, which is provided by the European Space Agency as a contribution to this. And this service module includes the power, propulsion, life support systems for Orion. Now, Orion will go to the Gateway, which is this orbital outpost in the vicinity of the Moon. This orbital outpost is made up of a power propulsion element and a number of pressurized modules. And ESA is providing one of these pressurized modules, called the International Habitat, and is also producing communication systems and in-flight refueling systems for this orbital outpost. And so this is somewhere where crews will go in deep space and will become a staging post to go from the vicinity of the Moon down to the lunar surface. So this will be somewhere where we go to stage down to the lunar surface and back. It'll be somewhere we go with crews to understand what it means to live and work in deep space. And it's going to be somewhere we go to perform fundamental scientific research. And then around the Moon, we want to support crews and activities that are taking place there. So this is also, we said, it's in the context of the Artemis program, which is a US-led program to go back to the Moon with humans, to do so in a way that allows sustained access to the surface for science and research, but also prepares for the onward steps to take humans to Mars. And as we see this ramping up of activity at the surface, all these different actors are going to need to communicate. And so we're preparing with our telecommunications directorate, who are also based at Harwell on the same site as well at Appleton. We're working with them to prepare a network, a communications relay network around the Moon with a number of spacecraft. And the first spacecraft to do this communications relay function is the Lunar Pathfinder, which is again being developed in the UK through with a company called Solar Satellite Technology as a partnership with ESA. A major theme of what we're doing is going to be lunar resources and understanding those resources. So the whole Moon is covered in powdered rocks. These rocks are about 40% oxygen, and everything else is different metals. So if we can pull the oxygen out of those rocks, we have something which is useful for propulsion and for life support systems, but it also gives us a residue which is metallic alloys, which we could use for in-space manufacturing. At the poles of the Moon, we find this water ice, which can be really helpful as to provide propellant and life support consumables. And so the Moon can be a source of propellants, of water, of building materials, of metals, and of oxygen. And so we need to understand how we can access these things, where they are, how we might use them in the future. There's a lot of effort going on now to define the research to understand these resources in their location and to understand how they might be used and extracted. And a major element of this is an international polar prospecting campaign. What you see here is a plot showing, based on temperatures made from orbit, where water ice could exist within about a meter of the surface at the lunar South Pole. And so there's been a lot of measurements made over the last couple of decades showing that there is water ice here. What we don't know is what the abundance is, the distribution, how it's associated with different regions, places, and environments. And so the next step is to get down to the lunar surface to make measurements at different locations that are comparable, that allow us to create an integrated geological model of water ice at the poles and to understand where the resource that we see now is actually the reserve that can be used. And so we're involved very much in this next step of exploration through a number of international projects. And the key to all of that is something called Prospect. So Prospect is The package that you see here, it's a drill and a chemical laboratory. Here you see it attached to the Russian Lunar 27 mission, which is planned for 2025. And Prospect will go into the polar regions. It will drill a meter beneath the surface, extract samples, transfer those samples to a chemical laboratory where they'll be heated. The water, ice, and other volatile chemicals will be extracted and will be analysed. And that will be analysed to understand its resource potential, but also to perform detailed scientific measurements to understand the origins, evolution, history, sources, and sinks of the volatile material that we find there. With this system, we can also do experiments to look at different resource extraction techniques to look at the ways, for example, we might be able to crack these minerals and extract oxygen from them, from the rocks themselves. This is important to note that this is the Prospect system is led by a company in Italy called Lunar, but the chemical laboratory package that's the really key part of this instrument is also a UK-led contribution, being led by the Open University with contributions from Airbus and from Rutherford Appleton laboratories as well. And this Prospect system has actually spawned, if you like, a family of exploration instrumentation, exploration payloads. So these are kind of a list of things that we're contributing to now in ESA. So with Roscosmos, we're working on the Lunar 25 and Lunar 27 missions. So Lunar 25, we're testing some navigation technologies. And then in Lunar 27, we'll be integrating that to provide precision landing and hazard avoidance for the mission and providing this Prospect package. Prospect is also flying now with a commercial lunar payload delivery that is being organised by NASA, and that's going to be planned again for 2025. From Prospect, there are two smaller payloads that have been developed, one of which come from one of the mass spectrometers, which is contained inside this chemical laboratory. The first of those has been delivered now and integrated with the top deck of the Astrobotic commercial spacecraft that will land it on the surface of the moon next year. And on the right-hand side, you see this instrument, this exosphere mass spectrometer in Rutherford Appleton being taken out of a test facility after testing. A spin out of that instrument is also now flying on a Japanese rover to explore the lunar poles called LUPEX, or the Lunar Polar Exploration Rover, and that's our plan for 2024. We're also working now on another NASA commercial delivery with a laser retroreflector that can be lased from Earth to precisely measure the range, so we can look at relativity and also the deep interior of the moon. And we're now just starting to work on an instrument to measure the environment of the lunar surface on a Chinese sample return mission called Chang'e 6, which will follow the successful Chang'e 5 as a part of what is an extraordinary and ambitious Chinese lunar exploration program, which plans to have what they call an international lunar research station in place by the end of the decade. Following on from that, we are trying to develop the next really big thing, which would be what we call the European Large Lunar Lander. The European Large Lunar Lander would be planned for delivery from around 2029. It's a logistics vehicle. It can provide logistics support in terms of delivering cargo to support human crews, and the Artemis program can also be used to deliver robotic missions and robotic equipment too. And so we've been looking into how this can support human exploration, but also the different kinds of scientific and robotic missions that can be carried to the lunar surface. And we're looking at robotic geological missions to explore the lunar poles and resources, missions to look at to do lunar astronomy from the lunar far side, to look at biological systems, but also to look at infrastructure we might deliver. So power systems, in situ resource utilization plants, other things like that. So, and over the coming years, we'll be down selecting what we're going to take to the next phase, also working with international partners, in particular NASA, to work out how we can slot this in as a service to support the human exploration missions. And one objective for ESA is to have a European on the moon by the end of this decade. And so as we look forwards, the reason we go to the moon is because the moon is the place where humanity is going to learn to live and work off-world, to prepare to go to Mars and beyond. The moon is where we're going to make scientific discoveries about our origins, about our future, and about our place in the cosmos. The moon will be the first place where humanity's economic sphere really expands beyond the Earth. And the moon is somewhere where the international community is going to establish the precedents for how we continue to explore the solar system together. And a lot of that's going to start in the next decade. The decade beyond that, it's really going to take off. And I hope that many of you will join us on what is going to be an incredible journey. Thank you very much.
Thank you, James. That was really, really interesting. Thanks so much. We've had a couple of questions come through. So first of all, we have a question from Jennifer. What will be the effect of extracting finite resource from the moon in the long term?
It's a really great question. It's also one that always comes up. And so this is a really interesting thing. So we have, and this is why I made a point of saying we need to learn how to extract and use local resources responsibly. So we're trying to work out, okay, there is an opportunity here. And someone's going to take that opportunity, right? So the Chinese are interested in this. The United States are interested in this. Right? We're interested in this. Japanese, everybody's going. Somebody's going to do it. And the challenge is, okay, this is going to happen. So how do we make sure this is done in a fair, responsible, and sustainable way? And actually, that what's there that's vast, the quantities of water ice, for example, that we're likely to find, and we're not likely to use it very quickly, but we need to be conscious that it is finite, but also that as we use this stuff, we will forever change the environments in which we find it. And that's not going to go away. You still see astronaut footprints on the moon from 60 years ago. You can still see them from orbit. Right? When you do something, it don't go away afterwards. And so I think this is a really important point. It's something that we're thinking about from a technological perspective, but there's also a lot of work going on, I think, at policy level, international level, within the United Nations and other places to try and understand what the norms, the rules will be for the use of space resources. And the first place we'll do that will be the moon. But then the use of space resources will most likely extend eventually beyond the moon to other places too. Couldn't tell you what the timescale will be for that, but it seems almost inevitable.
Thank you. Thanks. Yeah. I was going to ask the same question, so thank you for asking that, Jennifer. So another question's come through from Taya. What are some of the early career pathways into ESA? Do you have any opportunities for people with non-technical backgrounds?
Right. So the standard, so for early career, there are, I think, 2 pathways into ESA. The first would be the young graduate trainee program. So every year there's a general announcements to recruit young graduate trainees. Young graduate trainees typically would have a master's degree and would come for a period of, I think it's 2 years with us, after which you maybe stay in the agency or maybe move on elsewhere. The other entry point would be as research fellows. So this would be post-PhD, and those are 2-year posts extendable to 3, where you would be coming and working typically on some self-standing research, working with us, but also starting to engage a little bit in the different projects and programs that we run to get some insight into how the agency works and to be able to contribute there. And yes, we are an agency with scientists, engineers, lawyers, accountants. It's a large organization where we need everything. So the opportunities for lots of different professional disciplines.
Thank you. Thanks. And on that as well, could you tell us a little bit more about your career path and how you got into the field of lunar exploration?
My background was in physics for space science and technology. I then my degree, my PhD was looking at the Mercury imaging X-ray spectrometer, which is on Bepi Colombo, working on the design development of that. Also ended up as a side project working on various other things on the space station and other things. Then after a PhD, continued working on these projects for a while at Leicester. And then I took a job at ESTEC, actually as a contractor, working for another company who were sort of working within ESTEC, as a deputy study scientist for a number of early mission studies, looking at Moon and Mars. Eventually, we ended up zooming in on sort of Moon missions, preparing those, and so I ended up getting involved in some of those preparatory works for the Moon. So I'm not a lunar scientist by background, but that's where the need was. I ended up getting involved in that now, and it's been quite a number of years, but the Moon is really taking off now.
Thank you. Yeah, I think that should be really inspiring for some of the people in the audience. It certainly was for me, at least.